everyone, and welcome back to the Water Online Show, powered by Water Online. I am your host, Travis Kennedy, publisher here at Water Online, and I could not be more excited about the topic that we are going to cover today. Here in the Water Online Show, we cover a lot of ground, whether that's contaminants or different ways to measure certain things or different ways to distribute water or treat water, and we cover the gamut. But today is a topic that has come up repeatedly with feedback from our listeners, our readers, our viewers. And the topic that we are going to dive into sits at the intersection of sustainability, cost control, treatment performance, and that is thermal reactivation. So for utilities that rely on granular activated carbon to tackle contaminants like our old friend PFAS, VOCs, emerging compounds, the question really isn't just how to remove them. It's, well, what happens next? So thermal reactivation offers a powerful path for us forward, restoring spent carbon to near virgin performance while reducing waste, lowering life cycle costs, and supporting circular economy goals. So really the benefits are endless here. So in this episode, we are going to explore how the reactivation process works, how it compares to carbon replacement and disposal, and what regulators and operators need to know, where this technology is headed as treatment demands continue to evolve. So without further ado, let's get into it and welcome our very special guest. She is none other than the world famous Elisa Mayerberger, applications engineer at globally recognized Calgon Carbon. Elisa, welcome to the Water Online Show.
Yeah, thank you so much for having me.
So one of the things I wanted to start with is it's always good to start with something that's documented. So you recently published a peer-reviewed study on potable reactivation. It was in the Remediation Journal. One thing I really wanted to sort of get this thing kicked off on is how this affected Calgon Carbon, but almost more importantly, how it affects the current and future customers in terms of what they're looking for and how they're looking to move forward with adopting reactivation. So maybe we can take it one step at a time. So what does this mean for Calgon Carbon?
Yeah, so back in August, we published our second peer-reviewed study, and the impact it's been groundbreaking. With 2 full-scale peer-reviewed publications, we are the most scientifically validated provider of GAC reactivation, which is super exciting for all of us here at Calgon Carbon. But, we've been operating full-scale reactivation facilities for decades, and we've been supporting thousands of municipal systems. So what this study really does is it helps us take that step further, that we don't just operate reactivation facilities, we are actively contributing to the science behind them. So when we see those gaps in the literature, gaps in industrial understanding, we make it a priority to address them, because really most of the peer-reviewed work that's available today focuses on bench scale experiments. And those studies are valuable, but they don't always reflect what's actually happening at the full-scale reactivation system. And, their utilities are asking for this data. They've been asking for data that represents actual operating conditions, not just these lab scale approximations. And our study provides that. It brings those full-scale measurements into the peer-reviewed space, and it's ultimately giving these utilities and these regulators a clearer, more realistic picture of the fate of PFAS. And, in our industry, there's no real shortage of white papers, internal reports.
That's true.
Self-published case studies. Exactly.
Yep.
They're informative, but they don't go through that rigorous, independent evaluation that peer review requires. These peer-reviewed studies are demanding transparency, validated methodology, and there's a good amount of external scrutiny. So taking advantage of these peer-reviewed studies, they're held to a higher standard because they have to withstand challenges from experts who have no stake in the outcome. And that's really why this publication matters so much for current and future customers. It's giving them something that they can trust, data that's been independently reviewed, vetted, validated. And so for Calgon Carbon, this study, it strengthens our position as the most scientifically grounded reactivation partner in the industry. And for the customers, it's providing that assurance that their decisions are supported by the high quality peer-reviewed evidence. And that's really the impact. It elevates the conversation, it builds trust, reinforces that. And when it comes to reactivation, Calgon carbon is leading not just in practice, but in science.
Yeah, that's you cannot understate that, right? So it's as if Calgon carbon is not just speaking to the science and reacting to the science. It's almost as if Calgon carbon is part of the science. And
Exactly.
no municipality out there wants to be the first to try something, right? And if they are, they want to make sure that it's going to work. There is no plan B out there when it comes to when the health of their constituents is at stake here. So the fact that it's peer reviewed, and this is now the second one that you've done,
Yep.
really speaks to just how ingrained in the fabric of this type of solution and solving the problem that it solves is comforting for our listeners out there that have questions, and many of them do. So maybe we stop there for a second and go back to basics. What is reactivation exactly? Like, how does that even work for those that might not understand the science behind it at a certain level? Just how would you describe what it even is?
Yeah, that's a great question. And the best place to start is really with the fundamentals because understanding the different options really helps to clarify why so many municipalities are choosing reactivation today. So, reactivation is, you can describe it as this high temperature thermal process, and that restores spent granular activated carbon to near virgin quality so that it can be subsequently reused. And this is mostly because over time, as you're using the carbon, it's absorbing contaminants, its pores fill up. So during the reactivation process, the carbon is exposed to these very high temperatures in a very controlled furnace environment. And this process can remove those absorbed contaminants and open up that pore structure. So conceptually, you can think of it as unlocking a bunch of tiny absorption sites that have been blocked during service. And the result is a material that performs at or near the level of virgin carbon, sometimes even better, depending on the water quality and the operating conditions.
Well, it's interesting because there's other avenues out there. So I'm curious
Mhm.
how it stacks up against, let me name three of them, right?
Sure.
How would it stack up against regeneration, incineration, and landfills?
Yeah, so when you compare reactivation to incineration or landfilling, the advantages are just, they're very stark. So
Yeah.
incineration destroys the carbon entirely,
Yeah.
which means utilities then have to purchase virgin carbon every time. Landfilling isn't much better. You're kind of just simply transferring the waste or the spent carbon and all the contaminants it contains to a new location.
So
So that alone, yeah, raises
uh,
some long-term issues.
it does, and on two levels. And tell me how far off base I am on this. One is
Mhm.
it costs extra money. Like,
Yeah.
so have you ever come across an overfunded municipality? I haven't. I don't know if you have, right? So I'd imagine that they want to keep an eye on what they need to spend. So
Yep.
this way is going to save them money, which is
Yep.
a fantastic thing, right? While also getting the job done at or very close to what typical virgin media would. Right.
Exactly.
And it's also to the second point that you made there. It's not taking the issue and the contaminants and basically moving them to somewhere else, like a landfill.
Yep.
Do I have that right? Did I nail that? All right.
You have that perfect, actually.
Excellent.
We need to
All right.
switch sides now.
Well,
I gotta interview you.
my peer reviewed piece will be out later this year on it. What so what about like regeneration? Can we talk about the comparison
Yes.
there? Let's go a little deeper there.
Yeah, so it's incredibly important to distinguish reactivation from regeneration.
Yeah.
These two terms are often used interchangeably, even though they're very, very different processes. So regeneration is a low temperature or chemical process that's only partially restoring the carbon. It doesn't fully restore the absorption capacity of the GAC, and because of that, your regeneration's delivering a media that's still partially used up. So its
Okay.
removal effectiveness isn't isn't as great. It depends on the type of absorbed PFAS. It's going to vary, but
That
in
makes sense.
addition to that, though, it does generate a concentrated liquid PFAS waste stream. and
Okay.
that costs money, right? That needs to be managed, it needs to be disposed of,
Right.
plus the environmental burden. In addition to that, it's not really used in potable water applications since the chemicals that are used to remove the PFAS from that GAC aren't actually NSF approved.
Real. Okay. So
Yep.
it's one of those terms that seems to be kind of mixed up, and the terminology
Yep.
just needs to be cleared up. If I'm reading you right, like we can't use these two terms interchangeably. There are distinct and stark contrasts between the two things. And along with that comes the inherent benefits that are typically associated now with reactivation. So as an audience, let's make sure we get this right. We want to make sure that we're using the right terminology because that's going to drastically affect the outcomes that we want to utilize. So if when municipalities are out there and they understand the problems that they have, but now they just want a partner, somebody to help them, right? Like, I mean, really, who better than a company that is part of the science versus being reactive to the science? But Calgon Carbon is out there, like I had mentioned earlier, globally recognized. If I was a municipality and I was looking for a reactivation partner, what should make one of them stand out in my mind? What are some of the key factors?
I would encourage them to think beyond just the basic service of
Okay.
taking spent carbon and returning reactivated media.
Okay.
Reactivation is very much a critical part of a treatment strategy, so it's just a part in a whole. Especially when PFAS and other emerging contaminants are involved, choosing the right partner, it matters. So one of the first things municipalities need to look out for is the GAC media quality.
Okay.
Not all reactivated carbon is created equal, and municipalities should feel confident that the media that they're receiving is going to meet their expectations in terms of performance. So, a strong reactivation partner is going to be able to demonstrate that their process restores absorption capacity and delivers consistent, reliable media quality. Another really big factor is proven PFAS destruction. You want to make
Hmm.
sure that the PFAS is not only coming off, but it's being destroyed. With
That's an important part.
PFAS,
That's a
yeah,
very important
that's a
part.
good
Right.
part.
Yeah.
It's an
All
added
right.
benefit.
Yep.
But yeah, it's not simply reactivated carbon. You need to know what's happening to the PFAS that's captured by that carbon. So a standout partner is going to have that independently reviewed destruction removal efficiency data. So like in our paper, that's showing those high level of PFAS destruction
Hmm.
during that thermal reactivation process.
Yeah.
So this is one of the reasons why we're so invested in peer-reviewed research is municipalities deserve transparency and they deserve data that's been validated by the experts outside a company.
Without a doubt. All of which is important. I mean, it goes right back to what we talked about, I mean, earlier, Lisa, which is the peer review, the importance of peer reviewed data,
Yep.
which Calgon Carbon is now associated with and has been for a while, specifically related to this topic. One question I do have about the science, though, and we had talked about when we compared it to landfills or regeneration, in other avenues, but when carbon is reactivated,
Mhm.
what exactly happens to the absorbed contaminants? Like, where do they go? Do they just disappear? Is it like a magic trick? What happens to the contaminants?
Yeah, that's a great question, and it's one we're hearing more often. So the short answer is this. In our in our process, those contaminants are not simply moved somewhere else.
Yeah.
We're seeing greater than 99.9% of the measured PFAS being destroyed under these very carefully controlled high temperature conditions. So
What was that
in other
percentage? What was that percentage?
greater than 99.9%. So
I'm no mathematician, but I don't think it gets better than that. But so that's impressive. But go ahead.
yeah. Yeah,
What were you
so I
saying?
mean, we're not just shifting PFAS from one place to another.
Right.
We're essentially working to end the life cycle of PFAS. Um, but yeah, in our study, we knew utilities and regulators needed more than assurances. They needed independently reviewed data.
Yeah.
to show what's happening to the PFAS during reactivation. Where is it going?
Right.
And so in our research, we looked not just at the carbon itself, but at the entire system. So we looked at the furnace, we looked at the off gas, the abatement system.
Mhm.
We designed the study to account for PFAS going in and tracked where it ended up in each of the phases coming out. And we did this through EPA recommended methodology. So we use EPA method OTM 45, OTM 50, EPA method 0010, and we calculated the DRE, or the destruction removal efficiency. And
Thank you for
it,
defining that one. I was going to ask my
yeah,
next question. All right.
yep,
Yeah.
destruction removal efficiency. Yeah,
Excellent.
and we, again, over 99.9% of PFAS. And not only that, but no products of, well, the products of incomplete combustion and reformed PFAS, we were non-detect. And not only this, but the fluoride containing off gases, they're treated through our abatement systems. And this is usually through a chemical scrubber that's
Yeah.
designed to remove acid gases. So we've kept pretty close account of everything. And everything's shown in the paper.
I mean, how excited were you and the team? How excited was everybody when you got the peer-reviewed results in? Like, there must have
Oh,
been some kind of party out there in Pittsburgh.
it was beautiful. It was a lot of hard work. A lot
Right.
of people spent a lot of time in this project, and we're all ecstatic.
So let's break it down to its core here. I want to be clear on this because you mentioned some statistics, but now I want to get into it a little bit further. When you hear, and I don't hear this much. In fact, I don't know if I've heard it yet, but I'm sure with Calgon Carbon being globally recognized for a lot of the solutions and the thought leadership behind the science, you may hear it out in the field. But if there's anybody out there claiming that reactivated carbon isn't as effective as virgin carbon, how do you respond?
I I always like to take a step back and ask the question of, well, what does the data show?
Bingo.
And
I knew you were going to
yep,
go there, Elisa. It all
what
comes
does
back
the
to the
data
data.
show?
Yeah.
Yep. And this is where, our experience across hundreds of utilities becomes incredibly valuable. So many of our customers have found that their reactivated carbon performs just as well as virgin carbon, and in some cases, even better. And that might sound surprising at first, but it makes sense when you consider that reactivated carbon, it's undergoing high temperatures, through that thermal treatment more than once. It's going through that reactivation kiln and opening up that pore structure, which in turn improves media performance. So, because of that, the reactivated carbon can sometimes be more efficient in the same application than, say, a virgin carbon that hasn't been exposed to that environment before. So, of course, the performance is always going to be dependent on site specifics, so like your water quality and your operational parameters. But the idea that reactivation or reactivated carbon is inherently inferior, it just isn't supported by the data.
Yeah, I say good day, sir, to that. This, yeah, exactly. This is advanced science in an industry where advanced science takes a while to come to light, and this is really exciting stuff. So, what I am curious about, and I asked this many of our guests, because there's municipalities out there that are faced with certain challenges that this type of science and this type of solution can help and benefit them. What advice would you give them in terms of what's the most logical first next step if they want to learn more?
Next logical first step is give us a call. We have technical sales representatives that are representing all the regions across the country, Canada, elsewhere. Everyone is more than willing to help. The TSRs are supported very greatly by application engineers such as myself. We are the resident experts in this field, and we are more than happy to help. We have the data behind us, we have the papers, we have the case studies. We have a lot to offer. But if they want to reach out to any of the TSRs, they could also reach out to us over on our website, or even learn more on nomorepfas.com. But yeah, I would say reach out, talk to us. We're more than happy to have the conversation.
It all starts with dialogue, right? What is the first step? Dialogue. Get
Yeah.
communication going. And I can't emphasize this enough. The data shows what it shows, and it's peer reviewed. And reactivation is here to stay. And the benefits of it, to the point of 99.9%, the benefits of it are countless. And we could spend all day talking about why this is the correct avenue to go for most, if not all. But I will spare our listeners and our viewers and let them get back to work. They've spent enough time here with us today. We try not to be too intrusive, but we try to bring them and all of you listeners and viewers out there all the knowledge, all the data we possibly can. That is why we interview the best known industry specific experts out there, of which Elisa Mayerberger is one. And Elisa, thank you so much for spending your time here with us on the Water Online Show. Cannot wait to have you back. I want to hear how this goes over the next however long, 6 to 12 months, because I have a feeling when we revisit this, reactivation is going to be considered most likely the most mainstream way to handle whatever contaminant issues that they're having. But thank you for being on the Water Online Show today.
Yeah, thank you for having me.
And for all of you out there, thank you for spending your time here with us. On behalf of all of us here at the Water Online Show, have a great day, and we will catch you next time.